And now we shall talk about composite functions. Alright, composite function simply means compose two functions. Alright, compose a new function given to you two original functions. Alright, and sometimes we might ask you to decompose a composite function also. Alright, yeah, so I have given two examples on the board. Alright, and note that with composite function we have got three rules to always follow. The first rule would be for GF, or let's just say we only work with GF today, it could be FG also, please don't get me wrong, alright? So let's just say I want you to look for the composite function of GF. So for this GF to exist, I must first check whether or not the range of F is equivalent or within the domain of G, because you are plugging F into G, you see? So the range of F must be equivalent or within the domain of G, alright? And what about rule number 2? If you were to have GF to be found, the composite function GF, the domain of GF must be equivalent or within the domain of F. Okay, the second function F, alright? What about rule number 3? Range of GF must be equivalent or within the range of G. Alright, so let's look at the first example. We have got Fx equals to 2x and Gx equals to sine x. And I bet you could draw F equals to 2x, which is a straight line, and that will give you a domain of x is an element of real number, and it will give you a range of y is an element of real number. And what then about Gx equals to sine x? It is a graph like this. Okay, we all know to draw that. Obviously, x can be any value, hence x is an element of real number, and G range would be y is from -1 to 1, because we do know that the sine graph, the cos graph always oscillate between -1 and 1, right? So now let's move on to finding the composite function GF, alright? So if it is GF, okay, it is some f that I got to plug into G, alright? So it is some 2x that I got to plug into Gx, okay? So if Gx is equals to sine x, this x and that x, okay, I need to now have 2x into here. You get what I mean? Alright, so you have got your GF to be sine 2x, and I bet you could draw this also. It is a graph like this, and it will still be oscillating between -1 and 1. Okay, so just by looking at this graph, what would the domain of GF be? Obviously, x is an element of real number. And what would the range of GF be? It should be y is from -1 to 1. So let's check against the three rules that I told you earlier. I said in order for this function to exist, your GF composite function to exist, you must have the range of F to be equivalent or within the domain of G. And as you can see, they are equivalent. Okay, and the second rule, I said, if GF were to exist, the domain of GF must be equivalent or within the domain of F. And this domain of F is simply x is an element of real number, and hence we got it the same. Okay, and what about the range of GF? The range of GF must be equivalent or within the range of G, and hence the range of G is over here, and again they are the same. Alright, so let's look at another example. We have got fx equals to x minus 5. It is again a linear function, and this is how you draw your linear function. Fx equals to x minus 5, and this linear function has got a domain of x is an element of real number, and a range of y is an element of real number. Okay, so linear is pretty straightforward. What about Gx equals to 1 over x minus 1, right? So this is something I've taught you in class, okay? We must first tell you asymptotes. You must first tell me what is your asymptote. So how do I tell asymptote? The moment a fraction with the denominator 0, that is when the fraction wouldn't be valid, isn't it? Hence, x cannot be 1, and therefore x equals to 1 would be the asymptote. And there is a plus 0 over here, do you recall? Hence, y equals to 0 is another asymptote. So put your asymptote first, x equals to 1, and y equals to 0. And since it is a 1, which is a positive value, you're going to draw on the first and the third quadrant. Okay? The graph looks like this. What is the domain of G? Obviously, x can be anything but not 1, because it is the asymptote. You will only approach it, but you will never cross it. And what about for the range of G? It is any value but not 0, because y equals to 0 is the asymptote. Alright? So now let's look at what is GF. GF means I'm going to have F to be plugged into G. So x minus 5 is what I got to put into my Gx, and hence it should be 1 over x minus 6. And I know to draw this. Asymptotes would be x equals to 6 and y equals to 0, hence it should be a graph like this. Okay, so by looking at this graph alone, what would the domain of GF be? It should be x is an element of real number but not 6. And what about for range? It is y is an element of real number but not 0. So let's check against the three rules again. Alright, so let's check against the three rules. The first one, GF were to exist if the range of F is equivalent to or within the domain of G, okay? And the second rule, the domain of GF, it's equivalent or within the domain of F. And the domain of F is this one. And isn't that within? Okay, because X is excluded and it is still within. And what about for the third rule? Range of GF is equivalent or within the range of G. And the range of GF, it's equivalent or within the range of G, and it is over here. Alright, yeah? So why do you need to remember the three rules? Because it is not all the time that you could draw your composite function. So the moment you can't draw your composite function, okay, of course, if it is a calculator, assume paper, use your case calculator to help you. If not, you might want to make use of the three rules to tell your domain and the range of your composite function. Alright?